All right, so next up is actually going to be a topic as well as some notation of something that we've actually seen a little bit of already, and that's going to be this notion of a conditional statement. So all a conditional statement is a fancy term that we give to a particular type of statement that has a really nice structure. The structure that these things are all going to take are all going to be this classic if-then structure, this idea of if some random thing occurs, then some other random thing is going to occur afterwards. These conditional statements are actually going to become extremely important. They're actually one of these super important fundamental building blocks of all of the logic that we're going to be using throughout this entire course. Also, for those of you that are in the computer sciencey world, you're going to see these different types of if-then structures occur all over the place. If you've written any line of code before, you've probably written an if statement, and all of those if statements are simply just conditional statements. So just like the world of if statements, we're going to have this kind of initial assumption that should be satisfied in order for us to get into this if-then structure, and we're going to refer to that kind of big initial assumption simply as this hypothesis. So the idea is that if some random hypothesis is met, I'm going to have something come out the back end of this thing. And the back end part of this is going to then be referred to as the conclusion. So sometimes these conditionals are referred to as if hypothesis, then conclusion, but that's too much to say, so we typically shorthand this as if P, where P is going to represent some kind of hypothesis, whatever I want to refer to it as. The other side is then going to say then Q. So that's one way to shorthand this thing, but as most mathematicians are, we're really lazy when it comes to notation, and that's even too much for us to write. So we typically shorthand this to even slightly more or slightly simpler notation, which is simply just going to be P and then an arrow to Q. So the idea is that if P occurs, then Q is going to occur, or simply P implies Q. Okay, so down below you actually see a few of these examples of conditional statements, some of which we've actually identified before, kind of seeing some of the guts of what makes some of these things true or false. The first one's actually going to be that statement that said, if P is some prime number, then this expression 2 to the P minus 1 is also going to be a prime number. Earlier we actually showed that this thing was false because we were actually able to identify a prime number that was a counterexample to this thing. And the idea is that we had to find some prime number that satisfied my hypothesis. So in that case, my initial assumption is going to be the fact that something was a prime number. And then what I had to do is I had to show that that thing broke the conclusion. In this case, it had to not satisfy this idea that 2 to the P minus 1 was also a prime number. And that's exactly what's coming into play in this case. You're going to have this hypothesis, this kind of initial assumption, and then there's going to be this conclusion that comes afterwards. Likewise, you can see that there's a whole other bunch of these things. You're going to have this idea that if you finish your homework, that's going to become your hypothesis. The idea is that then you can play video games, that becomes your conclusion. If it's not raining outside, that's my hypothesis. Then it's not cloudy, that's going to become my conclusion. The idea is that sometimes we can phrase these things slightly differently. The idea is that instead of just using constant if then over and over and over again, I could say something like every time x is an even number. Well, that's still going to be embedding this notion of what my hypothesis is. I'm still kind of making this assumption that x is going to be an even number, so that's my hypothesis. And what's going to happen is that after the fact, I'm going to say something about x squared also being an even number. So in that case, even though it doesn't look like a classic if-then statement, it is still going to be one of these conditional statements. There's still a hypothesis, and then there's going to be a conclusion afterwards. And last but not least, I actually had this one that we just looked at, this idea that if I start with some random non-negative integer, I'm claiming that n squared minus n plus 41 is going to be prime. So in that case, we also saw that that thing is a false statement because I could find some non-negative integer. So the idea is that I can find something that satisfies that hypothesis, but it's going to fail that conclusion. So it's going to be this kind of weird kind of dynamic coming into play. Okay, so let's just look at one more example of one of these things before we dive into trying to determine when these things are actually going to be saying something truthful or possibly lying. So the idea is that sometimes these conditional statements can actually become quite large. And as we go into the logic component of this course, you're going to see some really, really big conditional statements. Sometimes these kind of things are going to be horribly nested. And that's kind of the exact same thing you can see when you're in the programming world. You can have these giant nested if statements. Or in this case, you can actually have an if statement that has two things that are going to feed into my assumption. The idea is that if it is not raining outside and the temperature is about 70 degrees, then I will go to the beach. The idea is that all of this stuff out in front, that's a terrible looking squiggly, the idea is that all of that stuff out in front must be satisfied in order for me to kind of officially say that I'm in my hypothesis world. I have to have that it is not raining and that the temperature is above 70. So in that case, there are two things feeding into this if structure, and then the back end part of this thing is still going to have this one fact that I will go to the beach. So in this case, the actual assumption or the hypothesis of this thing is exactly this part 4, or that fourth thing down in this case. The idea is that it's got to be not raining and the temperature has to be above 70 degrees.